We have a second keynote, Professor Ciprano.
So, be prepared to be late. I'm Italian, and I will keep faith about that. And therefore, I start immediately to lose time telling two words about my university, just to show the commonality that we have with yours. So, Padre University is the second oldest university in the world. We have 60,000 students. We have around 4,000 academics. And my department is the Department of Management and Engineering. And we have mechatronics, management engineering, basically the same things as your department. We have 2,500 students and 45 professors, but unfortunately only 20 staff supporting us. So we really value you about that point. We have also a PhD course in mechatronics and another in management engineering, and this course has been the first in Italy, opened in 1980. For 10 years has been the only PhD course in management engineering in Italy. So basically we are the father of the discipline in our country. And from this year we are totally open to international students. Our lessons are only in English, and also the application may be done from other parts of the world. It has been a long path, but finally we succeeded in the international. Thank you, Zoran, thank you, Robert, to invite me to be here. And thank you to the colleagues and friends of Novi Sad, which is a city that we like. And as to prove that, I was here only 1 day, but on holidays, just to see the city with family. So, and the last 4 years, for 5 years that I visited this part of the world, I noticed two very nice things, in my opinion. The big development of the area that took jobs also from Italy, unfortunately, and but this is a good point, and also is related with our research. So carry on the research here in this in the eastern part of Europe, open new possibility for West and Eastern collaboration, and also to bring some experience to raise new research questions. So very interesting and very good news for this part of the world. And also I felt the perception of more relaxed world, and that's also a nice thing. So thank you for all this progress, and to happy Friday. So let's go to the presentation. Let me skip the agenda. So I gain 1 minute. Customization and operational performance. What is the relationship? Very fast. Customization versus cost. Customization increase procurement cost. Increase inbound logistic cost. Increase manufacturing cost. Increase outbound logistic costs. And also increase marketing and sales cost. It was more difficult to read the demand. Here, the example of music is also more difficult to sell. How much time do the salesmen spend with customized products? It requires more effort in the technical office and the R&D department. It requires more resources on the human resource side, and also in all the infrastructural activities. So if we look at the indirect cost, the ratio between indirect cost and direct cost, we will notice something like 10, 20, 30% more. So this ratio is much higher in a customized situation than in standard situation. So customization is a trade-off with costs. Customization versus time. Again, the same. We increase the product development time. Why? Because you have to think to do more possibilities. Or because you are occupied with answering to the orders and you don't have time for the new product development. And so the time passes. There is a longer lead time in answering to the customer request and in delivering the products, because you have to make some further checks, to make some further activities, and therefore in totally the implication of variety and customization on all the time performances is also the dependability on the delivery time is getting worse. Customization versus quality. Again, we have a lower performance. If you have many different things to take care, it is easier to fail something. In terms of quality performance, we have a mixed effect. On one side, we have that the customized products is more tailored to the needs of the specific customer, and therefore it's a better quality. But on the other side, we have lower process capabilities, and therefore there are more chances that there is a lower quality performance. In terms of post-sales, the situation is worse because you cannot keep all the spare parts. Your cost of a warehouse will be impossible. And also lower reliability. And since we have less studies on the durability, on the fault tree analysis and things like that, also the duration is negatively affected. Generally, also due to the learning curve that are always at the beginning, the impact of variety customization on quality tend to be a negative impact, except for the better fit, which is very important, and also may affect the cost in a positive way. So generally, we have a trade-off between variety and variety customization and operational performance. How can we overcome this negative impact? We know mass customization. And what is mass customization? Already Frank told us. Let me recall, however, the definition of PINE, mass customization goal. We can define mass customization, and we also saw from the words of Frank, in two ways. One way is the performance side, and the other way is the capability side. What we have to know to do, able to do in order to reach the performance. So from the performance side, mass customization goal is that of developing, producing, marketing, and delivering affordable goods. So the cost, the price, we can afford that cost, that price, and services with enough variety, not total variety, not infinite variety on every aspect. Enough variety and customization that nearly everyone, not necessarily everyone, find exactly what she wants. So that nearly and that enough is a very important question in the definition. On the capability side, we can see the three pillars of pillar. So sorry for the joke. And I don't repeat them. Change words, but the same situation. In order to reach this situation, this capability of mass customization, however, we may have two different paths. We may arrive from mass production, and let's say most of the examples provided by Frank are from this side, or we may arrive from custom production. Only 2 or 3 examples that Frank provided are from this side. Actually, my origin is more from, my studies are more from custom, from engineering products, from B2B products, while Frank's presentation is more on the other side. So the two presentations in some way not planned, but complement each other. At the end we arrive at the same conclusion, however. and that's nice. And but what are the levers that we can use? We already had single minute standardized flexible manufacturing system, flexible workers, past standardization, product modularization, product platform, form postponement, and product configurators. Product configurators may help us a lot in reaching this mass customization capability. What are product configurators? How do they work? In order to understand this, I will provide an example taken from the custom manufacturing, from B2B products. And we will see how the process is changed by the introduction of this product configurator, and how the operational performance is changed. In this way, I introduce the topic for both for who know the topic very well and for who has touched only sometimes this topic, and I hope to try to satisfy the audience in both ways. Let's say the product is a voltage transformer. A voltage transformer is a product that has several characteristics that can be customized. Is the voltage in input, the different voltage in outputs, the different power in outputs, the ordering of the outputs, the way it is constructed, vertical or horizontal, the connection star or triangle, and things like that. The company that we analyzed had, I don't remember, but there was many thousands of different configurations, and if I remember well, something 1,000 new configuration per year, so something like that. It was not a big company, by the way. The traditional process was the following. The customer contacted the salesman, they exchanged information, and but the salesman was not able to deliver, to give all the answers that the customer asked for, and therefore the salesman contacted several times the designer to have the needed the technical advice. They needed. Once they finished this talk, they had the so-called commercial specification of the ordered product variant. So from commercial point of view, we have everything on place, everything defined. At that point, the engineers looked whether the variant was already produced in order to find the bill of materials, the routings, and the other production documents. But many times it was not possible to find it, 1,000 times at least per year. And the designer had to complete the definition of the specifications, adding some technical specifications that were dependent from the commercial ones, but still needed in order to be able to produce the production documentation. Check for feasibility, and at the end generates the production documentation. At this point, the production assembly the transformer, paint it, apply the label, and perform quality control of the final product. In this process, however, there were a number of problems. The first problem was that the chat between the customer and salesman, and between the salesman and engineers, repeated several times with cycles. And this repetition of the cycle led to long lead time in defining the products. So just before ordering the product, they had to spend 1, 2, 3, 4, 5 days. Days that are still stolen from the production later on. In addition to this, there were a number of misunderstandings and also some missed information. So at the end, the commercial work was not properly done. On the design phase, we have another problem. Since the designer was not sure to find out the product documentation, if he had only a little doubt about that, instead of searching, redesign the product. And therefore we have a number of redesigning of existing products. And also this guy was doing some repetitive activities, intelligent activities, because they require a lot of knowledge about the product and about the processes, but repetitive. They were not innovative activities. They were not innovating. Finally, in the production, the result was that the bill of materials had some problems, and therefore the material management was negatively affected. And if material management is negatively affected, you have also the delays in production, and at the end you do not respect the delivery date. Is this situation typical only of this company, or is this situation common? With the survey, we provide an answer, and the result is that 65% of our companies say that the commercial people doesn't have enough product information. They have difficulty in defining all products that can be realized and all products that are realized. What does it mean? The commercial people that sells what the company is able to do doesn't know what the company has done and is able to do. So it is not selling the capability of the company. So the company has the cost and doesn't sell what they are able to do. So it's the same message as Frank. A problem maybe in the sales side. The difficulty in estimating product cost. Imagine who has to give immediately a price or an idea of price that doesn't know exactly the cost, or can make some big mistake on the cost. This is an immediate impact on the margin. But they recognize that all this situation was possible to improve. So they recognize that there are approaches, tools, instruments, modalities, way of doing that can improve a lot of the situation. And on the technical office, 56% of the respondents said that the personnel is too much involved in the tendering process. They don't do the engineers, they are doing sales management in some way. And they spend a lot of time to produce documentation, not to innovate products. And at the end, the tenders, in any case, have a number of errors. And they are in a situation where the tendering lead time is crucial. And with the crisis, is more crucial and more crucial and more crucial. Because there are a lot of people that are offering in a shorter time than you. And since the customer are waiting the last minute to place the request, because they have a lot of uncertainty, time is crucial. So what we saw in the case is a common problem of a lot of companies. That's especially in the B2B environment. So we introduced the product configurator, and what happened? The customer asks information to the salesman, communicate preferences, the salesman provide information, ask for further preferences, translate the preferences in a product specification, and input the specification on the product configurator. Instead of contacting the design, the engineer, to have a technical advice, he asks technical advice to the product configurator. That
it's a fuse.
Okay, while you solve the problem, I tell the story. It's not so nice without it. So the product configurator what does? Provide answer to this technical request, providing data, drawings, and so on, and check also for the answer whether they are meaningful or not, and check the completeness of the questions and the answer. At that point, what happened? The commercial configuration is ready, and the product configurator take the commercial configurator and the commercial configuration and analyzes this commercial configuration. If it finds a already produced product variant that satisfies all the requests, immediately find out the product code, and with the product code has all the bill of material and routines. If this variant does not exist, it's not produced before, he goes to another module inside the product configurator and try to apply some rules that are able to fill in some missed information and to automatically produce bill of material, routines, and code. This happens for simple products, but for very complex products, this is not possible. For the complex products, it is needed the support of an engineer that analyzes the commercial specifications and based on his knowledge on particularly Excel sheets with complicated formulas from electrical engineering and so on, he finds out the missing information, the additional technical information that complete the commercial technical specification. Once this specification, the configurator, however, check the congruency of this for the specification. If you put that my shoulders are 2 meters large, as I did with the configuration of the shirt, the configurator said, no, it's wrong, please put the right number. And the configuration made some of these checks, and at the end, when everything is completed, produce automatically bill of material and routines. Oh, no. What is the result of the introduction? Later on, when you have the bill of material routines, you go to production and as before. What is the impact of this introduction, this change in the processes on the performance? First, the fact that the product configurator give immediate feedback, immediate answer to the request of the customer, eliminated the need to circulate information with the designer, and therefore the time, the answering time to the customer request has been shortened a lot. So instead of 5 days to complete the order definition, the order definition is done in half an hour together with the customer. This is first result. Since the check of the existence of a product variance is done automatically, if it exists, it is founded. So no redesign of already existing products. The repetitive activities are automated, and therefore the engineer does not perform anymore repetitive activities. The engineer performs only intelligent activities and activities that are seldom done. So we use the engineer for his upper experience and not for repetitive activities. It means that the engineer has more time and they devote more time and immediately to the more complicated orders. If the simple orders are done automatically and therefore are much faster. So in both cases the answer of the engineer is faster, and therefore, thank you, the time needed to have the product documentation ready is shortened, and the documentation is a good documentation without errors. Bill of material without error eliminate the problems in material management and eliminates the delay in production. And this animation is nice. It's a merit of Fabrizio, because this part of Fabrizio is done by Fabrizio. And so, the fact that you introduce at that point the product configurator reduces the exchange information. Introduce here the product configurator, change the typical path. So most of the time is something already done. And here we have support and check. So another point is when the designer receives the request to do something more, they don't, the instrument doesn't tell do this offer. The support say do this offer. All this stuff is already done. You have to change it to answer to this point, which is a much more focused work. You have to do only 2% of the work, not 100%. So it is not half an hour, it's 5 minutes. Okay. Impact on performances. Reduction in lead time to answer to customer requests, reduction in configuration errors. We said existing products aren't redesigned, automatic execution of repetitive activities, and bill of material without errors, and materials running and management much better. So our product configuration process is therefore something that take the request, the need of the customer, said in simple terms and current language like light bicycle, transform it in something which is a technical description of commercial technical description, aluminium frame model Impala of the bicycle, and at the end, bill of materials, routings, and eventually drawings. That's the process. The basic functions that are provided by the configurator are communicating the company product offerings to the customer, checking the completeness and validity, providing real-time information on price and cost, making quotation, and generating the product data necessary to build the product value requested by the customer. Later on in the presentation, I will call all this stuff product configuration use. A product configuration use of a company is higher if the company uses more this set of functionalities. Let's see now the impact of product configurator on the operational performances, looking at what the research in the last 20 years is telling us. This is the overview, very clear for everybody, because you can read also the number of the year, the number of photos, everything. I think that what you can see that from 89 up to 95, there is some research, but not a lot. From 95 up to now, the research increased a lot. First thing. Second thing, we have basically the research is based on cases. One exploratory survey on the expected results, not in the real results of mine. I can criticize it. The first literature review in 2007 by Heiskala and friends in Finland. And in 2011, the first theory testing survey. So basically, we developed our knowledge based on case studies. Let's say that 99% of the research is based on case studies, anecdotal or deep case studies, both. But it is we know that the research cycle starts with a case anecdotal, goes on with deep case studies. Later on, you have a descriptive survey, and at the end, you have a theory testing surveys. And after 20 years, it's time to try to test our theories. Or better, it's time to formulate our theories in form of theories and to test them, trying to look at the boundary of validity of our theories. Otherwise, we continue to accumulate knowledge, but we don't formalize it, and we don't prove that our knowledge is valid. And for this reason, I spend some words on the research, the theory testing research. First, the product configurator impacts on time performance. The result is that the use of product configurator has a positive effect on time performance. So, what the case studies told is confirmed by the theory testing survey. The sample is international sample, a company in USA, Asia, and Europe. And the measure of time performance is the following one. On-time delivery, fast delivery, cycle time from raw materials to delivery, and the speed of introduction of new products. This year, however, the time performance is not affected only by the product configurator. If the time performance is important for you, you work on the setup time reduction, on flexible manufacturing, you do a number of actions to be good in the time performance. And therefore, if you are working on flexible manufacturing system and the product configuration, the improvement in time performance is due to product configurator or to flexible manufacturing system. Maybe that I find out the correlation, but it is a poor correlation, because since I have done both things, I improved the performance, but because of flexible manufacturing, not because of product configurator. So we checked for that, and we controlled for time-based management practices and for time goal importance. So we the study considered whether the level of importance of time performance for the company and the level of the other managerial practices that impact on time performance. The result is that even though we take out this effect, the additional effect of product configurator is meaningful. So, yes, product configurator helps. That's the bottom line. But when you formalize a theory, it is not sufficient to say that this variable impacts on the other variable. You should say why. What is the mechanisms that transform a change in the value of this variable on another value of the other variable? So what is the mechanism of impact? This is important to understand the dynamics and the cause-effect relationship. And looking at the literature, we can identify three mechanisms. One is the reduced reliance on ad hoc solutions to fulfill idiosyncratic customer needs. So there are less customization. We reuse the analysis done by Muesli. A lot of people reuse the same stuff. But it's the system that brings the people to reuse the same stuff. Otherwise, you have the salesmen that push the customer towards the more customized product. Okay. Second, this is a reduction in the product configuration errors. And third, there is the reduction of workload for designers, because we free them from repetitive activities and so on. I don't go in detail of these three mechanisms, but all of these three explain the impact of a product configurator on time performance. What about quality? Again, the same result. The use of product configurator has a positive effect on product quality once we have a control for quality management practices and quality goal importance. What is product quality? The study used the definition of Garvin, 84, that product quality is a primary product performance characteristic, speed of car, secondary option car features, the navigator, reliability of the product, doesn't break the car, conformance to established standards, the seat should be yellow and it is blue, no conformance, durability, like my Skoda, 20 years, and serviceability, wonderful Brazilians women with a whiskey that helped me to pass the time during the service of the Skoda, and aesthetics and overall product perceived quality. So it is important, this measure, because it's not looking only at customer satisfaction, as a number of studies do in quality management. The quality product measure is a more subtle measure, and look at, especially for engineering products, is very important to look at the quality of product, which is what usually the customer go to measure to see whether the product is good or not for him. They professionally take this measure, and therefore it's important to look at this definition of product quality. The underlying mechanisms, again, 3 of the previous mechanisms support also the impact on product quality, but on top of these we have other 2 mechanisms that are better match between each customer idiosyncratic needs and the product solutions delivered by the company. Again, what Frank told before, the importance to define the good product space. And an additional mechanism is a faster adoption of enhanced products and process solutions. When you have found a problem in one bill of material, probably this problem touches other 20 bill of material. Not only this, but if you have an improvement in the technical solution of this type of table, probably the same technical solution can be transferred on that product. If you have a product configurator, you change the rule on this family of products and you have done everything. Immediately operative for all products. But if you don't have a product configurator, you have to tell to each engineer of each family product, please remember that you have to use this. Please remember, and they don't help it. They don't listen you typically. And therefore the improvements takes time to be diffused across the products. But on that research we see a step further. A step further is a contingency effect. We've heard many times that the product configuration issue is different from issue to issue. So it's changed in function of the context. But sometimes we will see that the same software performs well or performs very badly, even in some way, in some not so different companies. So we have to check about that. And if the same people with the same software have different results, probably there is something that changes the effectiveness of product configurator. And if we look in very carefully in the literature, there are some suggestions about that. And probably the moderating variable is the difficulty of market needs determination. It's difficult to determine a heterogeneous market demand. And if it is more and more difficult, it's more and more difficult to have the good solution space, as Frank told before. But if you don't have the good solution space, all the mechanisms that we stressed before are not moderated by, not affected by the configurator, because you go back to the original process. And in effect, this is the situation. You can see the relationship between product configurator use and the product quality. If the difficulty of market need determination is low, you have a very good relationship. Strong A little change in the product configuration use make a good change in the performance. And very statistically, from a statistical point of view, very significant. If you go with high difficulty of market need determination, you change the product configuration you use, but you don't change the performance. And the statistical significance is very low. The lesson is product configurator is really useful for product quality if you have a clear view of the needs of the customer. If you don't have a clear need of the customer, don't implement a product configurator, you save money. But this is very relevant for practitioners. And we have to take into consideration this kind of aspect. And why for me is important at this point? Because we should move from a general indication to indications that are valid in specific context. And we found out one reason that makes an important contingency. It means 100,000 euro saved. Months of work saved. That's what we are speaking about. And the third question, and the third performance, operational performance, what is the impact of a product configurator on cost? Who will test it? Who will test it? Next job. We don't have theory testing on that important side. Then can we measure and tell how much is the impact of the introduction of product configurator on the cost of the company? Now we have the information about the time and quality, and part of this can be transformed in a cost. But we have also a number of other things to investigate on that side. I like theater. To be or not to be? This is the question. Wow. But in this case, the question is, what is the impact of product configurator on the return on investment? On the balance sheet, we make our balance sheet analysis. What is the impact of a product configurator on ROI? Very relevant for managers, very relevant for entrepreneurs. But we don't have research on that point. It's very interesting for closing the gap that was telling Frank before me. And what is the pathway to answer? But first, we should ask ourselves, what is the effect of product configurator on sales, volume, and margins? We have some knowledge about that. We know that the product variety and customization may backfire. You said before the mass confusion. And okay, we know a number of mechanisms of the mass confusion. Marketing studies provide us a lot of information about that. But we, specifically for the product configurator, we should ask, what are the product configurator capabilities that facilitate customer choice? And if they facilitate customer choice, they increase volume of sales. And what is given the same product space, we may have better, higher sales if we have if we make the choice easier for the customer. Second issue. Can we sell more the customization service? So communicating better the customization value. If we communicate better, we can increase the price because we are selling the value. But how should be designed? So it is not only which characteristics, technical characteristics, Paul Brazek, you are studying the technical characteristics. But probably there is a number of a certain combination of these technical characteristics that lead to this capability. Therefore, we can have this capability realized in different ways. So it is, we should ask we need a concept which is intermediate, which is less fine-grained, less, let's say, detailed than the technical characteristics that you are looking for, but more detailed than the three capabilities provided by Frank. Something in the middle, in certain way. So that's what I personally see as an area of research to make the knowledge on this side deeper. And okay, we consider the numerator of the rate of the measurement. We should look in a greater detail also the cost part of the numerator, and probably also look at something about the denominator in terms of investments. And we should estimate the cost of product configuration implementation and the cost of the product configurator maintenance. We had some research. Let's look at the research of Lars Baum and his colleagues from DTU in Lyngby. They have done a wonderful research on this maintenance and a way to develop to implement a product configurator. But also a lot of people from Finland are working on this side. So we have a research on that, but this research does not transform in numbers in terms of euros. Okay, I gave the possibility of to research something more. So thank you. Voila. And I think I was right in telling that I will finish late.
So, should we go to the coffee or maybe one person?
Question.
Okay.
Please. To discuss about the product configurator. For point of view of artificial intelligence, it's some kind of expert system.
Yeah.
And the question, how we can trust the product configurator? For instance, in your case, I'm a customer, you are a salesman. I give you the order, you consult the product configurator, I buy from you that transformer, put in my machine, after 1 day, I have the failure. Who will be the guilty?
I changed the question. And if instead of the configurator, the production of bill of materials and the routings would have been done by your engineer, who is guilty?
Engineer.
Engineer? Okay. In that case, is the knowledge engineer. Why? Either because he put the wrong knowledge,
Yes.
or because he didn't check the quality of the product configurator. So we have two sources of, actually in this case we have three sources of errors. One, the customer used the voltage transformation without the control for spikes. Okay, your fault. Second issue, the expert in electricity provided us with the good knowledge, but I wrote the wrong rules. Is a knowledge engineer fault, so who implemented the product configurator. Third case, he provided us with the wrong knowledge. It means that the knowledge of a company is wrong, because it didn't develop and so on. In that case, the product configurator doesn't do anything different from what the company would have done. But actually, when you write down the knowledge into the product configurator, usually you perform much more checks than the engineers are usually doing. And therefore, usually this knowledge is better, and with the passing of time is tested and tested by different wrong, terrible customers in a different situation, and therefore we learn also the wrong use of the product configurator, of the voltage transformation, and we will put some checks about the environment of user. And therefore, at the end, the knowledge that is used is more controlled and much more advanced than the knowledge of Zoran, Igor, Elisa, and so on. Okay, I answered.
Is there any case that the product configurator was built by customer or many customers or the market generally, rather than only from the company? I mean that usually...
I again transform the question. There are some software vendors that sell the product configurator, actually doesn't sell the product configurator, sell the service to implement the models. So give the product configurator for free and you pay for all the rest of the service. And they will set up the model with the help, obviously, of the expert within the company. There are other software houses that sell the product configurator, and if you like, you can implement the product configurator by yourself without having any support from the company. And there are others that do a prototype, something in the middle. I never see the product configurator implemented by the market. I only see these two opposite and all the cases in the middle. In terms of what is more effective and more convenient, again, it depends on the context. If you would like to make this cost a total variable cost, you would like to have your IT a variable cost externalized, and you should have a very person competent in the modelization of the issue and on the tool. In that case, to externalize is a good solution. Why not? But if you would keep all the knowledge inside, not to spread to, and you have a certain size, and therefore you can have a group of 3, 4, 7 people, in that case the internal options is a very valuable option. So really, it depends on the organizational context and also on the cost structure that you would like to have.
Configuration implementation for different kind of products, so that you have understanding of what are the complexity limits of application of a configurator.
I'm sorry, I started very different products.